So now let's talk about this remainder theorem. So let's look at the special case, not like the last example we just did, but when the divisor is linear. So it just has an x as opposed to an x squared or x cubed. It just has an x. For the remainder to be lower than that, then it's going to have to be a constant. It's not going to be able to have any variable in it whatsoever. So, and it could possibly even be 0. So what the remainder theorem tells us is this: if we figure out what the x value would be in here to make this factor equal 0, and we substitute it into our actual polynomial, then we'll be able to come up with the remainder automatically. So what good does this do us? Well, what it does for us is if we get some number other than 0, it tells us that this is not a factor of the polynomial. If we get a number that's 0, it tells us that this is a factor of the polynomial. So, for instance, let's take this example. Let's find the remainder of 4x to the 5th x cubed plus 1 if it's being divided by x minus 5. Now, x minus 5 is a linear term, so we're able to do this and apply the remainder theorem. So let's say x is going to equal 5, because if we substituted 5 in here, 5 minus 5 would equal 0. Okay, so now we're going to take this value of 5 and actually put it into the polynomial. So 4 times 5 to the 5th power minus 5 cubed plus 1. All right, so 5 to the 5th power, 25, 125, 625. Why am I not coming up with 5 to the 5th power in my head? I'm getting 3125. So that's 4 times 3125 minus, and then 5 cubed is that 125 I was talking about. So 5 cubed is 125 plus 1. 4 times 3125 gets me 12,500 minus 125 plus 1. So minus 25 plus 1. Oh my goodness, I'm just not even able to do all this. So 12,500 minus 125 plus 1 gets me 12,376. So that would actually be our remainder. And what this tells us is that x minus 5, so x minus 5 is not a factor of the polynomial. Okay, so what I want you to notice, though, that the remainder theorem has its limitations. It only applies when you're dividing by a linear factor. So this x had to be to the 1st power. And it does not produce a quotient. So if we were actually looking at what the answer is when we do this division, we can't get it using the remainder theorem. The only thing it does is give you a quick way to find the remainder and determine whether this is actually a factor of the polynomial.